Thank you for joining us today for our G2I community session. Today, we are talking about managing technical debt with AI. This is our sixth and final session of our 6 month exploration of AI powered development. Today, we're going to hear from Matt Whitworth, head of engineering at Syncura, where he shares practical strategies for using AI to identify, manage, and reduce technical debt. Specifically, we'll learn how to leverage AI tools to modernize legacy systems and make data-driven decisions about technical debt remediation. My name is Michelle Bakels. I'm the host today. I am a senior technical program director at G2I. Most of you here are probably members of the G2I community, but just in case you aren't, a little bit about us. It's our mission to create custom talent pipelines so that our clients don't have to. We have a unique approach that combines customizable vetting, flexible terms, and tailored customer service that gives us an advantage. So whether you're hiring 1,000 engineers to work on complex AI projects or highly skilled individuals for your MVP, we can scale to your needs. Lastly, since we grew up in the open source ecosystem, we host an annual software developers conference called React Miami every April. We just finished that up a few weeks ago, but we are happy to announce that we are bringing that back for 2026 and that tickets are already on sale. So you can check that out at reactmiami.com if you're interested in that. As far as today goes, let's just go over a few rules of engagement. So as you'll notice in Zoom here, we have two different sections for chat and questions. So feel free to leave your comments throughout the presentation in the chat. Matt is going to be focused on his presentation, so he's not going to be responding to those right away. But please do feel free to leave your thoughts over there. We can address anything after the fact. There's a separate section for Q&A for questions. So after Matt's presentation is over, we're going to go through those questions in a separate section. So anytime during the presentation you think of a question, throw it in there and we will get back to it at the end. And although Matt's not going to be reading the chat throughout the presentation, there are emoji reactions that you can leave that he will see. So if he makes a funny joke, leave a laughing emoji. If he says something good, do a clapping emoji. When you're doing these virtual events as a speaker, sometimes it can be hard to gauge how you're doing, quote unquote, on stage. So these emoji reactions help a lot. So yeah, about Matt, he is the head of engineering again at Syncura with over 15 years of engineering leadership experience. His background in financial software development at Bloomberg and expertise in building sustainable engineering practices makes him uniquely qualified to address the challenges of technical debt management. So without further ado, I'm going to hand it over to Matt to kick us off on this really exciting topic today. Welcome, Matt.
Thanks, Michelle, and thanks very much for that introduction. So I'll just go through a couple of slides because I think it's really great to get a good handle on technical debt and what it really is as a whole. And then I've located at least one tool that I think is going to be really useful for everybody straight off the bat. So really today I'd like to tackle a subject I think affects any organization. Michelle and I were talking before, and really if you're even just one person working on a project, a couple of weeks in, you still perhaps to some extent have some technical debt. Really it's the hidden cost of quick fixes and legacy code, and that kind of ends up slightly draining momentum and inflating your roadmap. Everything becomes a bit harder to work on as a result of it. I believe there's a space for AI here, and it doesn't have to be expensive tooling, because I think with a good prompts, library of prompts and some time, you can gain a lot of insight into an existing code base. So probably not a particularly new definition to anybody, especially since I briefly mentioned what it was, but I just lifted this definition from Wikipedia, and I think the debt metaphor, of course, is a deliberate one. Just as with financial debt, you can take shortcuts, you can get immediate benefits, but really you're racking up a cost for the long term. And in the case of technical debt, the cost you pay is increased complexity, increased burden of maintenance, and of course just higher costs down the road because of it. It takes more time, it takes more mental energy to work on the code. It's just not as easy as it could be. So at its core, technical debt is really just the cost of choosing a quick short-term solution over a more robust, more long-term one. And I think the important thing to define from the start here is that it's a contextual problem. One team's idea of a quick hack is totally dependent on what the future looks like for the product and the code base. So really, how does it manifest? What are the symptoms that we end up seeing? We end up with a system that's really hard to understand, hard to change, or both. To kind of go back to that, quick fixes often help us meet deadlines, but create bigger problems down the road. But there's other forms in which we see it. Poor documentation, for example, if nobody understands what the code actually does, or rather what it's intended to do, it makes it kind of hard to judge whether the current behavior is actually the intended behavior. Outdated dependencies are another good one. They can easily drown a team in upgrade compatibility issues and hidden security risks. Code that doesn't follow standards is confusing and kind of hard for teams to maintain. If you find yourself reading the same region of code again and again, or thinking, wait, what? Then chances are it could do with a little bit of tidying up, a bit of work. It's slowing you down. And another classic one, and I'm sure something we've all had experience with, is missing tests. And these days, there's very few excuses for at least not having a good system for fixing this step by step. Every change becomes risky, and bugs, of course, are more likely to slip through, which just slows you down even more. So really, all of those are things that strike one project or another at some point in time. But really, the worst kind of problem that you can have is often the problem that you don't realize you have, something that's lurking below the surface. So how do we end up here in a project? How do code bases get to this point? Fundamentally, it's a resource problem. You cut corners because there's just no time, or you need to deliver something right away, and for a particular case. So you do it just for that case, you end up with a solution that works, but isn't the best solution it could possibly be. Sometimes that kind of schedule pressure, of course, is just outside of your control. It's just an organizational symptom that ends up reflecting itself in the code base. But I would say if you're working on a feature or addressing a bug and you're changing code in the meantime, even just stemming the bleeding, so to speak, kind of preventing further issues from happening, is definitely a step in the right direction. And that applies to a wider dimension within the team. If you as a team or your team doesn't have a shared idea of what good actually looks like, you're going to have messy, inconsistent code in general. You obviously have things like linters, code reviews, etc. to establish some base, but some of the problems that we're talking about are a bit more subjective, a bit more high level. So what you can do is use each review or discussion to build a style guide, principle by principle, one at a time. You can use that as input, as further context into whatever tool that you find yourself using here. And I'm going to show you a good example of where that kind of context would definitely help analyze technical debt and get over things there. So another great example, I'm sure we've all told ourselves this kind of excuse at least once, is we'll fix it later. It's just piling more work on future you. At the very least, you have to record the fact that you have to do it, or face the fact that it's never going to happen unless you spend an extra 15 minutes on the task now. But you could say that's possibly a problem of discipline or time management there. Testing is often skipped because it's just seen as too time consuming or too distracting or somehow too expensive. And another symptom you often see is because you're looking at other things, that you're in the weeds as such, that there isn't the time to develop knowledge. And so that can kind of be a self-perpetuating cycle that can kind of lead to mistakes and poor technical decisions, and those might compound over time. And now we have all of this. We have AI slop, some quick, careless integration of AI code that just ends up creating new technical debt that, again, compounds the problem. So I say in general, these are really just due to a few underlying factors. A reactive approach, of course, means that we only address problems after they cause us trouble. Resource constraints, which everybody is under, like time or focus or people, force us to put off important maintenance and fixes as a team. Prioritization is another big one. It means that technical debt, of course, just gets pushed to the bottom of the list. There's always something a little more urgent or a little more important there. And some of it is just the mental cost of thinking about a problem. It's just one more thing to think about. And that kind of approach means we just end up putting what we have, the kind of problem that we have or might have till later, because we just don't have the mental capacity to kind of think about it right now. What I would say is reason for optimism here, and I think it's something where other tooling can help, is that it's fundamentally a high context problem. So that's in opposition to, say, code generation, where you are developing something hopefully new by definition, and what's happening there is it's trying to guess what you would like to achieve. I mean, this is more talking about tab completion. With agents, etc. these days, you can specify a lot of what you would like the solution to be. But at least with looking at existing code base, you have all the context, at least code-wise, that you need. You can then ask questions of it. You can engage in a dialogue with it. You can provide it the external context that it needs to be able to make a good decision, and also the factors by which you end up prioritizing technical debt. We said it was subjective. Well, what are the factors that go into that? And I think just kind of looking at that from that angle, reviewing technical debt is a summarization problem. It's distilling key points of information from a very large base of text, and that's something that LLMs and models in general have been able to do for a while. It's a relatively easy and reliable task for them. And in something this scale of a large code base, it benefits from the trend of ever-growing context windows that we see in the latest models. So things are heading really in the right direction there. So as I was saying, it's not perfect context. It's impossible to provide it to the LLM. And in my view, there's always going to be space for human judgment here. Analyzing the structure and architecture of a code base is one thing. We've had tooling like linters for a long time that have helped us do that. This quote that I've got for a recent article on the subject is talking about all the human factors and the trade-offs that actually go into addressing good technical debt. And fundamentally, AI sees code as instructions, not the stories, not the constraints, the politics, the underlying reasons that brought the state of things into its current being. And without this, the model is never really going to understand the why and never give you the best, because it doesn't have that context, give you the best possible answers to the problem or the right guide, I think, at this point, unless you provide it, unless you can express it in those terms there too. And that's just the past and the present. You've also got the dimension of the future. We were saying again earlier on that some of this is, well, things can stay in their current state. If they don't need to change for whatever reason, then is it really technical debt that you have to pay back now? But forward-looking, knowing what you need to do next, what's important, relatively speaking, is considering the future. And that's what you need to fix, what can wait, definitely depends really on what's coming up there. So what can you do about technical debt? There's a bunch of AI tools out there that can help with the following. And my intention for this talk is not to go and recommend a whole bunch of SaaS services that you can try out. There's tons of them, and it's a fairly early market, obviously more mature in some areas than others, but some of them are quite domain specific there. And I think some of the greatest value in discussing technical debt is looking at things from a high level perspective. Am I even looking at the right thing? Am I even thinking about the right thing? Am I aware of all the problems that I have there too? So I want to focus on the underlying theory. Hopefully you find these slides useful as a reference later on, and give you a tool that everybody can use right now for free. A tool that can both prepare your code base for analysis and provide you with a set of general, well-specified, precise prompts on a range of subjects. So there's not really a need to reinvent the wheel by trying to pin down all the angles of technical debt that we discussed, you can actually get started in the next few minutes with this. So I have a demo prepared. This is based on, well, any kind of project you can use this for. I'm going to just briefly get set up with things here. So you should be able to see Complexity and this tool, Codebase Digest here. So this really is fundamentally performing two operations for you. So it's looking at your code base as a set of text files, but it's really packing what it sees, or a subdirectory of that repository perhaps, into a single output, and you can kind of copy and paste that output into any LLM you have. It gives you a bunch of statistics, some summaries, etc., but that doesn't really go beyond what other tools might provide you. That's one angle. The second, and one I found quite helpful over time, is the prompt library that it gives you. The way in which it specifies these operations is something that it would generally take quite a lot of effort to replicate. And you can see here, I'm sort of scrolling down from all of these prompt categories. What we've got is really several sections, really several dimensions in which to extract the intelligence that kind of underlies the code base. What I'll pay attention to, because we're talking about technical debt, are really architecture and design, maybe performance optimization, and code evolution and history. Where are we now? Where could we be going with this? That's something where you can give an LLM the code base it needs, the goal it needs, and the context. So before we just go with an example, we can see the kind of how specific these prompts are and how they may go about helping us there too. So if we take a look at code evolution history, well, technical debt estimation, not that there's any single one magic prompt, but some of addressing the health of a code base is coming up with new ideas, new fresh angles to the problem. So some of these, it can even pack up the commit history, so you can really take a look to see if somebody was hacking around at a particular point in the past and that behavior is still present there. There's other, I think, more generic things like the code quality indicators. Are we looking at things in a particular area that we keep on working over that needs some improvement there? Then I think estimating the impact, we were saying earlier, is a subjective decision, and there's nothing wrong with you supplying the LLM saying, please rate it on these factors. But having something that can give you some quick wins out of a code base is already the right kind of start there. So prioritizing areas for refactoring, sometimes it's just what's the impact of this and what's the effort that I actually have to perform to be able to do this well. And with agents and co-pilots, the cost of change, of course, is generally speaking going down there too. So I talked about going through an example. What I have here, can everyone see my terminal window? I hope so. So yes, good. So what I'm looking at here is I've installed Code Digest. It's just a Python pip package. Again, you can run it anywhere there. It gives you really a single text file is the best way to put it, but really something you can then place into an LLM, and what I'm going to use is Perplexity. Here, now I've done this -- copy to clipboard, I can now take really the subdirectory. I mean, I can actually do the whole directory, and maybe this will exclude the commit history, but I have these Python files here. There's just 2 of them, but I can already show you that even though this is a relatively small open source project, and to give you context here, this is implementing an outlier detection algorithm for streaming data. It was something I used in the past. I'm sure, like most open source projects, they would be happy to see the architecture improve, to see the code quality improve there. It gives me some ideas for doing that. And often when you're contributing to a new open source project, you don't know quite where to start. But if you can spend some time analyzing it, getting a sense of the state of play, then you can go from there. So anyway, I've copied it to the clipboard. If I if I copy it again, what we should see here is it generates a file, and going back to this prompt library, well, we might not have the commit history because we just included the directory with the code in. But if I paste this prompt, actually this full prompt, not just that section, then I think we'll get some pretty interesting results from this. At least when I tried this before, I was quite impressed. And this is with the search models, so lower level, not quite as many interim steps. You could try it with a reasoning LLM, a kind of R1 and other reasoning approaches, and see where you go from that. So I think this is there we go. So this is the bit where you can see I think let's turn it on to the research side of things. There's a bunch of things that you could do locally here. Now what I have to do is place that back in, but that should only take a second. I may have to talk you through some other elements here. What it's going to do is break it down and try and analyze things as you might do. And I think one of the most interesting aspects of it, yes, the reasoning might not be perfect, is that you can see the kind of the approach it's going to take, what it's going to check, how it's going to relate what it's found to other things there too. And a lot of the value in this exercise is almost in how should I go about thinking about this, and how to structure it there too. So there are some lower level metrics that you could see here, like cyclomatic complexity, function of the number of loops and if conditions and maintainability. Some of these things end up being checked by lower level tooling. In general, what we're more interested in is how someone might approach it from a higher level perspective. Not necessarily what are the individual things at the line level going wrong, but fundamentally, should we be re-architecturing this to make it more extensible? What would we need to do there? I found, at least locally, the R1 tends to do a pretty good job of this there. We can come back to this in a few minutes, actually. If there's any questions to take, it might be a good time to take them now. And then we can take a look at the result together and kind of come back to these kind of things as well.
Okay, so we do have a question that we can start with. This one is from Ethan. I'm the only one who understands certain parts of our system because I've been here the longest. How can AI help distribute this knowledge so it's not all in my head?
Good question. And this is a kind of situation I've been in myself as well. So the important part, like with anything, is to break it down. You might know quite a lot of things, but not everything needs to be transmitted all at once to somebody else. And often there's going to be some hot and cold parts of the code base, and you should have a pretty good feeling for what's hot, what's cold in terms of changes and what might need to come up there. And I always have this feeling, of course, of wanting to do a good job and wanting to say, well, here's everything, here's all the issues, here's the most context that I can possibly give you there as well. It's what I found best is kind of restraining that natural instinct and saying, well, I'm going to constrain what I share here to that right now, and then I might have a plan later on. So I kind of kept like a little to-do list saying, okay, there might be this new developer joining the team. I'm going to give myself a sense of progress There, in terms of tooling in general, yes, there are some good documentation generation tools. The only gotcha, of course, is what exactly the context they're working from is. I've seen some impressive things that result from looking at the code, but then also you can, sort of slow playing a lot of Notion pages, wiki, things like that, in the hope that it can work out what the decision-making process was that led to it, and of course the key factor here, what the intended behavior was meant to be. But the higher level, you can keep that goal. The higher level, you can have it, and that you can make the use of your time there. That's the only thing really a human can do.
Yeah, that is such a good question, and definitely difficult, I would say, to try and parse out the right use AI to like parse out the right context. So having some guidance, of course, will help. But I mean, how much of technical debt can we say we know is attributed to situations like this where maybe the person who wrote the code isn't any longer with the company, and all of the context around the logical implementation is lost or undocumented. And so now everybody's kind of afraid to touch it because they're afraid to break something. So yeah, I think that this is a good opportunity. There's another question from Matthias. Testing has always been our weakness. Again, 10 out of 10 relatable probably for everyone here.
Yes.
And now it's coming back to haunt us. How can AI help us identify critical test coverage gaps in a way that feels manageable to address? Such a good question because I personally see testing as like this use case for AI that keeps getting mentioned over and over again. But like quality tests are obviously better than the quantity of tests. So what do you think?
I think it's definitely more of an art than a science. We've been on possibly teams which have encouraged high code coverage, but then you get the feeling like, oh, it's not really testing it, or I don't really feel like it's getting the range of the functionality that I actually want to test. You don't feel as if it is full coverage that it's actually helping you that much there too. So some of this is you have to break it down to two parts. I think one of it is, can you test it? And architecturally, I think that's where AI can really help. If it's just the collection of all the good architectural principles that make your code testable, that's a great place to start. Like if you're getting into a point where your code is becoming more testable, and because you haven't written in a way before, that's the thing that's been stopping you, then that's a pretty good start. And what we've seen so far, of course, just points you all in the right direction there. So the second part I'd say is, in terms of writing tests, yeah, there's tooling out there, etc. I am a little skeptical of it because I think you do need human level reasoning. I think you do need a really good sense of the intended behavior that you actually want to test, and what's a representative set of test cases. But also, if your constraint is, we're so busy that we can't even devote a lot of time to thinking about that, then any step is a step in the right direction. Getting it can usually have a pretty good guess, if you've labeled things well, at what representative set of test cases might be. And I've been in those kind of teams before. Once you stem the bleeding, you find yourself with more time, there are less incidents, then suddenly a lot of these more positive coding practices, especially ones that humans are very useful for, that require judgment, it gets you into a nice positive cycle, and that's a much more pleasant team to work in.
Eddie brings up a good point in the chat. Testability is a huge factor of standards of development and architecture. I'm hoping my team currently head in that direction with little nudges in a change culturally. Cultural changes it's hard to understate that as like potentially the biggest blocker of good testing and decent testing in an application, probably more than any other tool can be given credit. Okay, I also want to acknowledge that we are waiting on your demo. So just give me a heads up when you're ready to jump back over to your presentation.
I can jump back now. Actually, it's
Okay,
finished.
then let's do
There,
the
it
rest
took a
of the
lot.
Q&A after.
That sounds good. Give people a break
Okay.
from having a break. So this, and it really depends a lot of the quality on the LLM that you end up running here. And we may not have time, or maybe we can pop back to it. There are other prompts that we can run, and I'll take a look at those too. What I'd say here is this is already a great start. You know, it's fine if you can get a list of reasons for doing things and a priority list of reasons, but if you have the reason behind those areas and you agree with that reasoning, that's already a great start. So it's saying here, because this is essentially maintaining a very big tree structure, it's saying, well, actually, if you insert a point into this tree-based thing, that's actually the highest complexity in the code base. And you know, a lot of the tooling that you could have used before could have analyzed that code there. Same with the class restructuring, but things like comments to code ratio is a big factor there. You can also reason about the impact. Old style tooling is not going to give you this, and you could argue a lot of the code complexity, code burden factors are the same, but it's also kind of nice to see, well, you know, testing the monolithic design of the RC tree, we haven't even looked at a single line of code, and we've already got a great idea of the numerous factors that are there. It looked at some of the commits around there, not very interesting, some of the things there, but really the recommendation is where should you start first? Well, just refactor the functions, then decompose the class, improve the docs, improve the test coverage there. Your mileage may vary. I found, depending on the kind of engine that I used, and you can rewrite this in various different engines, that you can end up with you'll figure out which one is best for your case there too. So don't think of this as a complete demo. Think of it as giving you a sense of what you could possibly do with the tool. Another interesting fact I found was identifying architectural layers and coupling cohesions. Those are almost perfect summary exercises where you don't want to be at the level of the code and having to understand everything in order to draw this high level picture. You want something to go away, understand it, give you that summary picture, and then of course that's a picture of the world that you can test by reading through the code yourself afterwards there too. So hopefully a good tool to pick up, very easy to install, and if you exercise a bit of judgment, it should help you, give you new ideas there. Yeah, I think with that we kind of conclude the demo and the presentation. So yeah, thanks very much to Michelle and to GTI for letting me host this. Great to be on, and I'll share a QR code on the screen as well while we're answering some questions that has the link to these slides. Hopefully they're a useful reference. I'm happy to take any further questions.
All right, so let us kick off our questions. Okay, so as AI tools become more sophisticated, do you anticipate a shift towards more preventative approaches to technical debt rather than remediation?
Good question.
That is a good question. Because it's the joke, right? That these tools are actually probably like a greater risk factor to technical debt than a helper, right?
Yeah, in the wrong hands for sure. And some of this, your context, the knowledge, you're never going to be able to replace. But what I think it will definitely do is reduce the time to an intermediate level. You know, you join a new company, get on track with the code base, and depending on how well they've optimized that workflow, it takes you an hour, a day, a week, or a month to really feel like you're in a good place to start contributing with confidence there. If you understand the underlying theory, like what good software architecture looks like, and hopefully you have others on the team that care about it, that make time for it, then these kind of tools will always point you in the right direction and give you the kind of structure that you need to address the problem there too. I had something else, but I also forgot. I'm interested to get your take here, Michelle.
Yeah, I think you see, especially if you're chronically online like I am, you see all of these like takes about don't learn how to code, like just learn how to use the AI tools. I'm kind of against that. I think learning to code and fundamentals is still so important, and I think like developing your technical acumen is still so important because I mean, just a show of hands in the emoji reactions or the chat, whichever, like how many of us have gotten a completely like heinous implementation suggestion from AI? Like where you know, because of your experience as a developer, that this is like a god awful implementation that you should not put into your code. I know I have that experience for sure. Where I'm just like, oh, thank God, like, because like I know that if I have a friend or something that is just kind of vibe coding through a project, they might just keep tab 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 or and you don't even realize these little kind of traps that are being laid around your application if you are not really familiar with how the code works. So I think that that's always going to be important personally.
Yeah.
So as far as like this question goes, I I'm not really sure how AI is going to shift towards preventative approaches, to be honest. I think not to sound, old school, but I think we still need to use our best judgment.
I think it's always a nice moment of superiority where I look at a suggestion. I think, oh, a lesser developer might be distracted by that, but I know it's wrong. So,
Someone less skilled in the craft may be tempted to
yeah,
accept this.
yeah. Some would say arrogance, but
Yeah, yeah. Okay, let's go to this question from John. How do you decide which technical debt to fix now versus later? Sometimes what seems minor ends up being critical, and sometimes what feels urgent can actually wait. What a timeless question, by the way.
yeah. So I'd say, and I was a little vague about it in the presentation, to be honest. What I think you can always divide things down into, if you're ever stuck, is effort versus impact. And then you can categorize, well, what does effort mean and what does impact mean? And that's the bit where it gets a bit subjective. But, effort is not only just the cost of making the change, but it's also the risk, the kind of effort that you have to apply behind it to make sure things are safe there too. Impact is, does this, how high traffic is this? How many people benefit this? How much on the critical path, or how often is it read that people will genuinely save time each time they look at it, and will also surface new issues as a result there too. And it's the nature of the problem that you can't know all of those things ahead of time, but you can also have a pretty good guess. And like that little matrix of effort versus impact, you can kind of figure out what's really high impact, low effort pretty quickly, and that at least gives you a pointer as to where to start there. Some of the AI models help, but you've got to rely on your own judgment for that in the long term.
Yeah, I like that matrix. Okay, so question from Eddie. You know what? Before, for whatever it's worth, before we started this session, I was like, I anticipate that this is going to be one of our more active Q&A sessions for our community. And I
Yes.
think I think we're proving this to be right now. Like this is definitely a very active Q&A. So thanks guys. I love all of the questions. Keep sending them because we can hang out. Okay, so as AI is becoming used for more things, how do we guard against hallucinations, strays from intended behavior, etc. for these useful tasks?
I think it goes back to some of the earlier points we were making. If you're not informed, and I think there's a distinction that we always have to make between, are we still learning about this? I think it's always a great heuristic to have as a developer is, do I really know enough about this to start making decisions about it? And so I'd say half of this, of what the tool I've shown you, certainly is useful for where do the things lie, the on the surface, or rather, just looking through the entirety of the code base, do the same factors keep popping up in every problem there? Now, I haven't tested this on very large code bases, and who knows, given the constraints of the context window, whether or not it's going to return you quality information. But also, you can subdivide this thing. You don't need to go and fix every subsystem at once. You don't need to understand everything at once there. So that maybe should help a little bit there. So slightly vague answer, but I think that kind of points things in the right direction.
Okay. Sorry, in my mind I had my own follow-up question and then I was like, no, let me prioritize the ones here. Okay. So do you think that it is possible that AI is creating a new kind of not so obvious technical debt that's harder to detect because it looks clean at first glance?
Yeah. And I think this angles towards the you end up with a new set of problems you don't realize you have. That's a real caution there. But we're getting into what are the limits of knowledge, how much can you know about something, and perhaps at some point how much that actually matters there too. I think
Yeah.
a great point for optimism there is that the principles of good software architecture are timeless. If things are not, you know, well, you followed all the kind of right things. You divided things well. You've made it clear. You've made it composable. Those things should be easy to spot there. But if you can't even detect it, even with a reading and thorough understanding of the code, again, is it a massive problem? Well, I don't know, but I don't think so.
Do you think that technical debt is just inevitable fact of software development?
Yes, very much so. I mean, in my new company, I've been working on something by myself for about 3 or 4 weeks, and I already feel like I have some technical debt. I've got to
Yeah.
deliver things early on. What I thought was the best way to go about it, and this speaks more to the domain and the problems I'm trying to solve. I now realize a couple of weeks later, well, actually, no, this is the best way to go, or it needs to be extensible for this. And I wrote it originally thinking we would never need to extend it there. So, yeah, it's almost impossible to avoid. I challenge anybody to have worked on a project that doesn't have it. I just think what differentiates the best from the worst, how you go about treating something that is essentially a small maintenance cost that if you don't pay, it turns into a very large one.
Yeah. Yeah, I think managing it is like it's like managing your health, or anything else. Like I've never been added. I don't know that I've ever been added to a code base where the developer that was working on it before didn't like apologize, like sorry, like don't judge what you see. Like, and I do that too, like sorry for what you're about to see. And it's just like this, like kind of leading me to this like idea that all software has like embarrassing code in it, especially if it gets to like a significant size and like, the idealistic clean code paradigm. It's always good to have like North Stars, but there's like a reality to this. So it's
Yeah.
like building things, trying to get them to work. All right. So okay, so that question we answered. Okay, so how do you integrate what we talked about into your regular development workflow? Do you run these analyses in CI/CD or is this more of a periodic assessment?
I'd say periodic assessment. And if you don't have the time to do that, well, that's your first problem. And I appreciate, some of that is saying, well, often it's pointing out the impact to the rest of the business. You can't imagine that everybody will be seized with the importance of working on it. So you have to say, well, actually, we could have done that in 2 days, but we spent 3 on this. If you start counting it in developer hours, developer days, and you're saying, well, actually, we can pay that back if we spend a tenth of that time just sorting things out, then that makes for an easier, you can allow time for each sprint or whatever methodology you might be using there. I think once you have that, you stop being reactive, you start being proactive about it. You think, and you do this effort impact, you realize, oh, it'll take me half an hour to fix this there. So it's one of those things where it's going to feel like a lot of effort, a lot of coordination the first time you do it, and then the cost just goes down. And then you think, okay, well, seemingly I don't have any technical debt at all. And then you reach out to me and Michelle and say, well, you were wrong. My project's perfect now.
That reminds me of what Eddie mentioned a little while ago about it being cultural. Yeah, I guess getting the consensus that it is worth paying down technical debt is definitely probably the biggest battle. What might a team intention okay I'm not sure what might a team intentionally incur technical debt and what are the potential risks of doing so. I'm not sure if I'm reading this right
Yeah,
or
I think that the answer is fairly simple. Like the
okay.
short term matters a hell of a lot more than the long term, and that's in some code bases that's all right. If you need to get something out for a demo for an important customer, yeah, of course, you might even hard code quite a few things to that. But if you're doing the same thing for something going into space for the next couple of years, then it might be best to argue to push the deadline back a little bit.
Yeah, definitely. There's definitely a risk assessment to incurring technical debt. Yeah, such a good question. Okay, now when I first read it, I wasn't really sure that I was understanding it, but once you started answering, I think I understand. I think even like yeah, I think there is just like this inevitable also like learning, I hate to like bring up the cliche of like move fast and break things, but there that is like a great way to learn what works and what doesn't work is to just try something and see what happens. So, okay, so the last question that we have here from Matthias, have you found that these tools are actually catching different types of technical debt than our traditional analysis tools, or is it mostly the same issues presented differently?
Yeah, and that's something I've always cared a lot about code quality and practically fixing it because I've seen and heard experiences of companies where it literally does affect them and even puts them out of business in some cases. Night Capital is a great example of that. So I think for me, a it's a sense of getting to the more subjective area, the more high level area that these tools show their promise and to some extent their value for more objective things, more lower level things, linters, code scanners, code ratings, things like code climate, for example, those will always have their place. And I think that's fine. And what I end up running, and I think that's alludes to my answer earlier on, you want those objective things. This is objectively not following our style, or this, is a more complicated way of expressing the same thing, is very much a CI/CD thing. We need to enforce that base level. But what do we work on next? What technical debt do we patch up next? Because that involves human judgment, that isn't a good place to put it in for CI/CD
Mm.
there, and you're dealing with a fundamentally different level of issue there. Hopefully, in a roundabout way, that answers your question.
Mhm. Okay, so that wrapped up our Q&A. We had 9 questions today. Nice, guys. Thanks.
That's
Um, So, with that said, I want to say thank you again, Matt, for joining us for the session again. We appreciate you presenting your knowledge. And just as a side note, like if you're watching and you're a part of the G2I community and you have something that you're really knowledgeable about or that you want to share with everyone, Thea, if you're in the G2I community, Thea. So reach out and share with her your ideas. We love all different topics. Does not have to be AI powered. Of course, we just did our 6 month AI powered development series, but we can talk about anything developer related that you think everyone will benefit from. So please share your ideas with Thea. Thank you again, Matt. One thing, you may remember from a previous session, I do like to give each presenter the opportunity to leave one last final thought for our group. So, any parting wisdom for us?
I would say you can always change quite a few things, even if you can't change everything. So figure out what it is, figure out if it's quick, do it. And for me, that's the rewarding part of the job. It's setting things on the right way. It's not about reaching perfection by tomorrow.
I love that. Okay.
Thanks.
All right. Thanks everyone for joining. Thank you again, Matt. Thank you, Thea, in the background. And we will see you guys at the next G2I event.
Great. Thanks. Bye bye.
Bye.